is the valence electron, but 1 is the combining power of chlorine. That's 1 electron needed to make this one now octet. So the valency of chlorine is 1. Likewise, that of sodium is 1. Then what's then the difference? Maybe for due explanation, what you need to know is that both are univalent. Because they will ask you in JAMB, in WAEC, which of the following elements has the same valency as chlorine. Sodium has the same valency of chlorine. In fact, group 1 metals, they have the same valency as chlorine. Then the difference now is that as metals form positive ion by loss of electron, then non-metals, they form negative ion by gain of what? Electrons. Now, sodium now is univalent positive ion. That word univalent means that its valence is 1. It combines with other elements by a loss of 1 electron. Likewise, the valency of chlorine is 1. That's why it's a univalent negative ion. The word negative, it just shows that it attached the electron, but the numerical value is 1. So the chlorine, you cannot say that the valence of chlorine is 7. No. Instead, what is 7 is the number of electrons in the outermost shell, the valence electron. But the valence, see the spelling, the valency of chlorine is 1. That's why we say that chlorine is univalent. But to distinguish it from that of the sodium, as we have written here, then sodium is a univalent positive ion, as we can see. Then chlorine is univalent negative ion. The same thing is applicable to calcium and oxygen. Calcium is 2882. That's 20 atomic number. Then the number of electrons in the outermost shell is 2. That's the number of valence electron, and that corresponds to the valency. It combines with other elements by loss of 2 electrons, and that's why we have calcium as divalent, because the valency is 2. Divalent positive ion, because it ionizes by loss of 2 electrons. Then at the same time, for oxygen, oxygen is number 8 atomic number. By looking at it like this, then the number of electrons in this outermost shell, I mean the number of valence electrons, is 6. But its valency is 2. I mean the combining power. It is easier for oxygen to accept, I mean to gain or attract 2 electrons to complete this number of electrons in the outermost shell to 8. That's to achieve octet structure. Oxygen reacts or combines by accepting 2 electrons. So that is the combining power. So the combining power or the valence of oxygen is 2. Then to distinguish it from that of calcium, then the calcium is divalent positive ion. Then oxygen is divalent negative ion. So in each case, the valency is 2. Then likewise in aluminum, aluminum is now trivalent. Then phosphorus is trivalent because it forms a more stable compound when it reacts by gaining 3 electrons than a valence of 5. The reaction involving a valence of 5 for phosphorus is not easily combined. But the most stable compound is when it combines with a valence of 3. Now look at this one now. The red gases, argon and helium. Argon has atomic number 18288. So the number of electrons in its outermost shell is 8. That's the number of valence electrons and not the valency. Likewise, for helium, the number of electrons in the outermost shell is 2. And we are not talking of the valency. Then when we come to the valency, both argon and helium, they are of valency 0, because they don't combine with other elements. They don't have that tendency to combine with other elements. So their valency in each case is 0. And that's why they can't have a charge. So I think you have learned something on the issue of valency and valence electron. Thank you.